How did Galileo prove Aristotle wrong about the speed of a falling body? By rolling bells down the slope. Subscribe now to the History of Math on the YouTube channel What Makes It Tick. Today, scientists have machines, lasers, video, camera, etc. But it was not always the case. Galileo, for example, 17th century, had no instruments at all. Nevertheless, he made some breakthrough in science. I'll give two examples, and the two examples are connected because twice he proved Aristotle wrong. First idea of Aristotle was a heavy body falls faster than a light body on the ground. Galileo said, no, it's not true. The speed is the same. He said, imagine a heavy rock and a light rock. Stick together. What's the speed of the fall? On one hand, the sum is heavier, should fall faster. But on the other hand, because of the light rock, it should slow the fall a little bit down. So this is a paradox. And the only way to get out of the paradox was to accept speeds are the same, whether it's heavy or light body falling to the ground. Another mistake of Aristotle, according to Galileo, was his belief that the speed of a falling body was a constant. 1 second, 1 meter, 2 seconds, 2, etc. Galileo was convinced, no, this is not true. There must be somewhere an acceleration, and he wanted to prove it. Of course, no camera, no laser, nothing to prove it with instruments. How did he do? He built a slope, a long slope, 16 meters, and let a ball roll along the like this. And then he said, I'm going to put some bells. His idea was, I cannot solve and I cannot prove the problem with my eyes, I will solve the problem with my ears. And along the slope, he put bells, equal distance. He let the ball roll, and what did he hear? Ping, 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 ping. The acceleration. He heard the acceleration. Incredible. Like this, Aristotle was proved wrong after 2,000 years. And Galileo didn't stop there. He said, okay, now I've proven the acceleration. Let's calculate it. So he started to play with the bells and organize them. And finally, he put the bell at 1, 2, 4, 8, 16 meters. And when he let the ball roll, he heard ping, 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 constant rhythm. It was proven. Acceleration is connected to the square of the distance. Amazing. Bravo, Galileo. Join us next time when we will admire one of Isaac Newton's most beautiful mathematical solutions. Subscribe now and follow the History of Math in the YouTube channel What Makes It Tick.